Hello everybody, in this video we will be starting with the chapter number 11 of ACCA F2, which is Analyzing Data. Before watching this video, make sure that you have checked the previous videos of the previous chapters. In case you haven't, then I've linked it in the description box below. So this is a very basic chapter since we have done most of them in the middle school. So let's get started. Make sure that you have a notebook and a pen and a calculator with you and you are solving and making notes along with me. In this chapter, we'll be basically learning how to calculate the mean, median and mode. We'll be able to see how to calculate the measures of dispersion, that is the variance, the standard deviation and the coefficient of variation. So we'll be seeing the statistical methods. It is quite simple and usually you are given most of the formulas in your exam. So let's get started. We've learned about what are the different sources of data and we learned how to present data. Now we are going to see how to interpret and analyze our data which we have collected. How do we analyze the data? Averaging them, measures of spread, expected values and normal distribution. These are the types using which you can analyze our data. So let's begin with an averaging data. What is averaging data? Okay, so we know that there are three different measures of average. We know mean, median and mode. We have heard about it. Mean is the average, median is the middle value, mode is something which is more frequently occurring in the given set of data. This is the basic stuff which we have been studying since childhood. So let's start with the arithmetic mean. So arithmetic mean is basically the average, right? And it is calculated by dividing the sum of the values by the number of values. So the sum of the total observations divided by my number of observations would give me my average. Total upon, what did we do? We used to do total cost divided by the total number of units in order to find the cost per unit. That is a method of mean, right? That is calculating the average only. So that is the same logic which we are using over here. Total divided by the number of units. So using the following set of numbers, how do I calculate the average or mean of this? Adding the number of observations divided by the number of adding the entire observations divided by the number of observations. That would be 12 plus 14 plus 17 plus 19 plus 15 divided by 5. Why? Because this is 1, 2, 3, 4, 5. That would give me my arithmetic mean. The measure is arithmetic mean, where there is no possibility of confusion, simply the mean. Okay. Illustration number 1. A shopkeeper is about to put his shop up for sale. As part of the details of the business, he wishes to quote the average weekly takings. So this is the takings of last 6 weeks. So what is my total number of observations? It is 6. So how am I going to find my mean of the following? I am going to add all these observations and divide it by 6. Let's try to do it. 1120 plus 990 plus 1040 plus 1030 plus 1105 plus 1015 divided by 6. That is going to give me 1050. Let's check the answer. My answer is 1050. So I don't think there's anything to explain in that. That's how you calculate your arithmetic mean. As we can see, this formula is easy to apply. However, we'll need some modification before it can be used to determine the mean from groups of data or a frequency distribution. So you must have studied frequency distribution table, right? Okay. Now how do I find out mean from a frequency distribution? A company is implementing an efficiency drive, and as part of a leaflet it is to distribute to its employees, it wishes to point out the average daily absenteeism rate. The following data is collated from the records of a sample of 200 working days. So compute the sample mean. So when I have X as well as F, I am going to calculate a new column of Fx where I am going to multiply F with X and write the value. Then my mean is going to be summation of Fx divided by the summation of F, right? Summation is basically the sum. The sum of the fx divided by the number of observations, which is the sum of the frequency. This will give me my arithmetic mean. X is given here, f is given here. You need to calculate fx. So 9 multiplied by 0 is 0, 28 multiplied by 28 is 28, 51 multiplied by 2. So like this you are going to calculate fx, then you will add the total fx, then you will be getting the summation of fx, and what is the total number of days, adding all this you will get. So dividing the summation of fx divided by sum of f will give me my arithmetic mean. It should be noted that the number of days column simply gives the frequency corresponding x values. So to find the mean, see this is, so whenever you see this in your exam, you need to know that this is the formula of arithmetic mean. Summation of fx divided by summation of f. So solution, x given in the question, f given in the question, fx, you are just multiplying the corresponding values. The total of fx is given over here, and the total of summation of f is also given over here. So this is, you need to find out, and then you just need to divide them, and the mean number of absentees is 3.7 per day. Simple. Let's begin with my test to understanding number 1. So we have f over here, we have x over here, and we have f over here. Let's find the fx of the same. 2 multiplied by 2, 4, 3 multiplied by 4, 12, 4 multiplied by 3, 12. So like this, multiply the corresponding values. I hope you're solving it along with me. Alright, now let me find the summation of f. My summation of f is going to be the sum of all of this. However, it is given over here that it is 22, so it's 22. And my summation of fx is going to be the sum of all of this. That would give me 1, 1, 1. So my arithmetic mean is summation of fx divided by my summation of f, which would be 1, 1, 1 divided by 2, 2. This is going to be 5045. I'm sorry, it is going to be 5.045. So that is going to be my 5 employees. So 5 employees is my mean. Okay. The following illustration demonstrates how to calculate the mean in a slightly more complex case where we have grouped data. Till now we had data which wasn't grouped in nature. Now we'll be having data which is grouped in nature. How are we supposed to calculate arithmetic mean when the data which is given is grouped? As part of its preparation for a wage negotiation, the HR manager of a company has collated the following data from a sample of pay slips. She wishes to be able to use the average weekly wage figure in negotiations. So we need to find out. Whenever you are given a grouped data, what do you understand by grouped data? When you have a particular group, the data is divided into group. So we don't have just one x, we have two x's, right? We have 8 also, 185 also, 185 also, 190 also. So here in the data we are not having a single x, we are having two x. So we are having the data which is divided in the form of groups. In this situations, you are supposed to find the value of x. So in order to find the value of x, you are going to take a midpoint. How do you find out a midpoint? This plus this divided by 2. So this is my x1, this is my x2. You just want to find x. So that would be x1 plus x2 divided by 2. Don't learn the formula, just apply some logic. Whenever you are given group data, you need to find out the midpoint. In order to find out the midpoint, what do? Initial point plus final point divided by 2, right? So that's what you are supposed to do over here also. Because we don't want to have two x's, we want just one x. So 180 plus 185 divided by 2, what is that going to be? 182.5. Try doing it with your calculator. 185 plus 190 divided by 2, we get 187.5. So that is how we are going to find out x. So that is basically the midpoint. You are adding x1 plus x2 divided by 2. So now you got the x value, and the value of f is given from before only, right? So now you have x also with you, you have f also with you. So fx is going to be the multiplication of the corresponding values. So by doing that you get your fx, and now you know how to calculate your arithmetic mean. Your arithmetic mean is going to be summation of fx divided by summation of f, which is 32,400 divided by 170. That gives you 190.56. So till now what we were doing? We were doing summation of fx upon x. But in group data you will be given two x's, right? Because it's given in a group. In such situation you are going to find out the average, which is the x1 plus x2 divided by 2. So that is like the midpoint. Beginning with test your understanding 2, again you have to find, you have x1, you have x2. So how am I going to find out the midpoint? X1 plus x2 divided by 2. This will basically give me x. So that is 350 plus 360 divided by 2. And here I'm going to do 360 plus 370 divided by 2. Here I'm going to do 370 plus 380 divided by 2. So by doing that you are going to calculate the midpoint. So that would be the values of x. Try to do it by yourself. So I have 355 over here, 365, 375, 385 and 395. So now I got my x and I got my f. So I have to calculate my fx, which is the multiplication of these. Multiply f with x. So I have 1420, 2190, 1875, 1540, 1185. So my summation of fx is going to be 8210. My summation of f is going to be 4 plus 6 plus 5 plus 4 plus 3, which is going to be 22. So my mean is going to be summation of fx divided by my summation of f, which is 8210 divided by 22. That would give me 373.18. Try to find out by yourself. If you haven't solved it yet, pause the video and try to solve it and check it with my answer. Okay, so this is very basic and very simple. I don't think we need to spend more time here. In fact, I've even solved the test your understanding for you. So we are done with our arithmetic mean. Now we'll be beginning with the median. The median is defined as the middle of a set of values when arranged in ascending or descending order. So whenever we are speaking about median, we are talking about the middle value, the value which is in the middle of the entire data. However, you need to make sure that in order to find the middle value, you need to arrange the data in either ascending order or descending order. So before attempting to find the median, you need to arrange the data in a particular order. The median can be used to overcome any issues of skewed data. So when you're talking about a skewed data, you are talking about the distribution that is not symmetrical in nature, since the median has half the distribution above it and half the distribution below it. Median is also unaffected by any large or unusual individual measurements. But when you're talking about mean, it is going to be affected by it. Illustration number 4. So we have been given the same data which was given in illustration before. Now we have to find the median of the same. So how am I going to do? First I am going to arrange this in ascending order, right? So 990, 105. So now it's arranged in ascending order. Alright. Now what is the middle value over here? If you think about it, I have 1, 2, 3, 4, 5, 6. Since I have an even number, there is no middle value. So in such situations, I will be taking the middle two values and finding the midpoint of it. So that would be 1030 plus 1040 divided by 2. I hope you understood what I did. If it is an odd number, if I had, let's say, if I had this as the next number, then I have 3 over here, 1040 would be my median. If that was a data set with odd number of observations. But here we are given the even number, so in that case I'll take the middle two values, add it and divide it by 2. So then I'll be getting the median. In case of an odd number of values, the determination of the median is even easier as there is a clear single item in odd number of values. That's what we saw in the example right now. If there are n observations, then the position of the median is given by n plus 1 divided by 2. With 6 observations, it gives n plus 1 divided by 2. So calculate the median of the following data. Is it odd number of observations or even number of observations? This is odd or even? Odd, right? So you have 2 over here, 2 over here. So my answer is 18. It's that simple. It's the middle data. In case 27 wasn't there and only this data is there, then I will add the middle 2 divided by 2. Now I'm beginning with my third thing, which is the mode. Now what is mode? Mode is the thing which has occurred the most frequent number of times. The mode or the modal value of a data set is that value that occurs most often. The determination of this value when you have raw data is to deal with consists simply of a counting process to find it. Now looking at this, so mode is something which has the highest frequency, the most frequently occurring data. So the highest frequency item will be the mode. So out of this, which is occurring most frequently? 12 times. Something is occurring 12 times as compared to the other frequencies. So my mode will be corresponding to 12, which is 1. Simple. Now looking at this, the test your understanding number 4. Now which one is occurring the most? 3, 3, 4, 4, 3, 3, 2, 2. Okay, in this entire data, what is occurring the most? The number 3 is occurring the maximum times as compared to 4 and 2. So my mode is going to be 3. Alright, now we'll come to a little bit advanced topic, which is the measures of spread. We have looked at averages. We will look at the measures of spread. Having obtained an average value to represent a set of data, it is natural to question the extent to which the single value is representative of the whole set. Through a simple example, we shall see the part of answer to this lies in how spread out the individual values around the average. In particular, we shall study the following measures of the spread. So we will be studying the standard deviation and variance. We will also be studying the coefficient of variance. Beginning with the standard deviation and variance. The standard deviation and the symbol of standard deviation will look something like this. So this is my standard deviation value. The standard deviation is a way of measuring how far away on average the data points are from the mean. So what does the standard deviation actually tell us? It tells us how far my number is from the mean or from the average. In other words, they measure average variability about the mean. As such, standard deviation is often used with mean when describing a data set. For example, suppose a data set has just 2 observations, 10 and 30. So tell me, what is the mean? 30 plus 10 divided by 2, total divided by the number of observations. That would give me 20. And the standard deviation will be 10, as both observations are 10 units away from the mean. Obviously, 10 is 10 units away from the mean, which is 20, and 30 is also 10 units away from the mean, which is 20. For more complex examples, calculating the standard deviation involves the following steps. Look at the difference between each data value and the mean. To get rid of the problem of negative differences, cancelling out positive ones, square the results. Work out the average squared difference, square root to get the standard deviation. So this is the formula of standard deviation. Okay. So what is my standard deviation formula? This summation of x minus the mean square divided by the number of observations. The variance is simply the standard deviation squared. For most calculations and discussion, standard deviation is perfectly adequate, but the variance is used in more advanced statistics and probability theory. So this would be the formula of the same. So this is how you calculate the standard deviation. However, if you want to find out the variance, that would be the square of my standard deviation. Okay, so I'm ending this video over here. In the next part of the video, we will be starting with my illustration number 6. So in the next video, we'll be doing the questions, all the questions, and then we'll be also seeing the coefficient of variations and expected values. Alright, let me just see how much is left. Okay, so in case you would like to watch the other chapters or you would like to solve the Kaplan exam kit, then I will be linking it in the description box below. So make sure that you do check it out in order to be thorough with the Kaplan exam kit as well. Thank you.